Let's determine what it means for a sequence to be bounded. If we have a sequence a sub n and we want to say it is bounded above, then there needs to exist some value, capital M, such that the sequence a sub n is less than m for every positive integer n. This means that no matter what index of a sub n we look at, the value will always be less than the value for m. If you were to draw this out, you would see a horizontal line at m, since m is just a real number, and the values of the sequence below it. You could then observe that none of the values of the sequence ever fall above the line at m. Conversely, if we want to say a sequence is bounded below, there would need to exist a real number capital N such that the sequence a sub n is greater than or equal to capital N for all positive integers little n. So no matter what index of a sub n we choose, we will always have a value greater than capital N. As before, drawing a representation of this would show a horizontal line at n and the values of the sequence above it. You would then see that no value of the sequence ever falls below the horizontal line at n. If both of these conditions are met, then the sequence is bounded above and below, and we just call this a bounded sequence. It is possible for a sequence to be unbounded below as well as unbounded above. In this case, the sequence is an unbounded sequence. It is important to note that all convergent sequences are bounded. However, a sequence that is bounded may not be convergent. Let's work through some examples of this. We want to determine if sequences a sub n equals 2 to the n times e to the n, b sub n equals 2 to the n over e to the n, c sub n equals e to the n over 2 to the n, and d sub n equals 1 over 2 to the n times e to the n are bounded. Since none of these sequences can ever have negative values, all of the sequences are bounded below by 0. We know this because 2 to the n and e to the n appear in each sequence, and neither of these functions can ever be negative. Let's look at a sub n first. We can see that the sequence is made up of a product of exponential functions and grows unbounded as n increases. This means that a sub n is only bounded below. For b sub n, note that 2 over e is less than 1, so we know that 2 over e raised to the n is also less than 1. So we can conclude that b sub n is bounded above by 1. Since we know that b sub n is bounded below by 0 and above by 1, we can say that b sub n is a bounded sequence. For c sub n, we have the opposite situation. In this case, we have e over 2, which is greater than 1. Therefore, this sequence will continue to get larger and thus is unbounded above. However, we determined at the beginning that c sub n is bounded below by 0. This is the only bounding that applies to c sub n. Finally, we know that 1 over 2e is less than 1, so 1 over 2e raised to the n is also less than 1. Therefore, d sub n is bounded above by 1 and quickly converges to 0. Summing up, a sub n and c sub n are unbounded, b sub n and d sub n are bounded.